Lesson 3-1, solving systems of equations by graphing. A system of equations is two or more equations that have the same variables. There's a lot of ways to solve systems of equations, but we're going to solve by graphing. And to do that, you graph the equations and you find the point where they cross, or the point of intersection, and that is the solution. So here's example 1. I want to graph the two equations, negative 2x plus 2y equals 4, and negative 4x plus y equals negative 1. I'm hoping that when I graph these two lines, they're going to crisscross at a point that I can identify on the graph. So let's get started. I think the easiest way to graph these is by setting them equal to y, putting them into slope-intercept form. So here's the first equation. Let's work with one at a time. Oops, sorry, it's a positive 4. Okay, I'm going to add 2x on both sides. Then we get 2y equals 2x plus 4. I always write my x term first, and then I'm going to divide everything by 2. Okay, so our equation in slope-intercept form is y equals x plus 2. Now this is helpful because I know that the y-intercept is 2, and I know that the slope is 1. So over on my graph, let's graph this line. Y-intercept of 2, slope of up 1 over 1. Now I'm going to make my line pretty long here because we want to find the point of intersection, and I'm not exactly sure where the two lines are going to cross. And so you can't make a short little line. You need to make your line go all the way across your graph. Okay, that's pretty good. Now, let's do the same thing with the second equation. So the second equation is negative 4x plus y equals negative 1. All I need to do is add 4x, and I'll have the equation in slope-intercept form. So y equals 4x minus 1. There we go. It's a negative 1 here, so it's minus 1. Now, negative 1 is my y-intercept. And then 4 over 1 is my slope. So from this point, I'm going to count up 4 over 1, up 4 over 1. I can go backwards, down 4 to the left 1, and now I've got points on this second line. Let's go ahead and connect them. Okay, now they do in fact cross, and they cross at a very specific point here. The point 1, 3 is on both lines. Now what that means is 1, 3 is our solution to this system. There's an easy way to check to make sure that you've got the right solution. Let me show you how to do it for this problem. Okay, so if I want to check that I found the correct intersection point here, you're going to check the x and the y values in the equation and make sure that the equation is satisfied. So here's the first equation. Negative 2. Now instead of x, I'm going to plug in 1, the x value from the point, plus 2 times our y value is 3, and I need to make sure that I get 4. I think it works. Negative 2 plus 6 is 4. Now it has to work in both equations, so I also need to check the second one. Negative 4 times 1 plus 3, does it give us negative 1? Well, negative 4 plus 3 equals negative 1, and so that one also checks. So for these two equations, the one point that satisfies both equations is x equals 1, y equals 3. Let's try a word problem. So the initial cost for Travis and his band to record their first CD was about $1,500. Each CD will cost $4 to produce. If they sell their CDs for $10 each, how many must they sell before they make a profit? So they start out with some costs, $1,500, and then $4 per CD. We need to write a cost equation, and as you can see from my graph, I'm letting x represent the number of CDs. So our cost equation is y equals $4 times x, $4 per CD, plus $1,500. That's the cost. Now the question is, how many CDs do they have to sell before they make a profit? And they're going to sell them for $10 each. Our second equation is y equals $10 times x, $10 per CD, and that's the profit equation. Now if we graph these two lines and figure out where they cross, we'll figure out the point when their profits and their costs are equal, and then beyond that, they should be making money. Okay, so let's go ahead and graph these. They're both in slope-intercept form. Notice on the y-axis I went up by 500s, and on the x-axis I went up by 50s. Okay, so the first equation, the y-intercept is 1500, and the slope is 4 over 1. Now I can't really go 4 over 1 here because I went by different scales. I went by 500s here, and I went by 50s on the bottom. So if my slope is 4, I want to think of a different equation that equals 4, but maybe just with bigger values. And here's one that works. If I count up 1,000 and then over 250, that's the same as 4. Up 1,000 over 250. So starting at my y-intercept, I'm going to go up 1,000 over to 250. And that is really the slope of 4. It doesn't look like it on here because I didn't use the same scale on x and y. So here's the first equation. And then the second equation is just y equals 10x. Same thing, if my slope is 10, that's kind of hard for me to do on this graph. I can't count up 10 over 1. That wouldn't be accurate. It wouldn't actually be a slope of 10 because, again, I went by 500s and 50s down here. So here's one that will work. If I go up 1,000 over 100, that's the same as 10 over 1. So that's the slope I'm going to use for this graph. Now, if you look at this equation, my y-intercept is really 0. I don't have a y-intercept, so I'm going to start at 0. I'm going to count up 1,000 over 100. That's the same as a slope of 10 over 1. There we go. And if I draw my line here, it looks like they're going to crisscross right here at 2,500, 250. All right. Sorry, I said that backwards. 250, 2,500. Okay, so the question is, how many CDs do they have to sell before they make a profit? And I want to look to my X values because my X values is the number of CDs. And so if I would answer this question, I would say 250 CDs. At that point, they'll make a profit and they'll start to make money. Okay, let's try another one, just plain old graph the equations. I want to show you a different way to graph here, and that would be using X and Y intercepts. So the first equation, 3x plus 4y equals 12. I'm going to graph this one in green. If I find x and y intercepts here, I'm going to get x equals 4 and y equals 3. That's my x-intercept, and this is my y-intercept. So I found two different points here. How did I get that? Well, 3 times 4 is 12, and 4 times 3 is 12, and so I know those are the intercepts. Okay, so x equals 4, y equals 3, and I can see that my slope will be down 3 over 4, down 3 over 4, or up 3 to the left 4. Here's the first line. Again, I need to make it long because I'm not quite sure where these two lines will intersect. And then my second line, I'm going to use intercepts again here. So if I want to find the x-intercept, I'm going to set 6x equal to negative 16. I can do that because when I plug in 0 for y, that term drops out. So I'm going to divide each side by 6. And negative 16 over 6 reduces to negative 8 over 3. Now I probably want this as a mixed number so I can figure out where to graph it. That would be at negative 2 2/3. That's my x-intercept, right about there. Let's find the y-intercept for this one. The y-intercept is easier. 8y equals negative 16. That means the y-intercept is negative 2. Right about there. Okay, let's see what we have here. Now if I connect these dots, it appears that the lines are parallel. Now, if I find the slope of the line here, let me just see what we get. If I take -8/3 and I divide by, oh no, if I take -2/3 and I divide by -8/3. I'm trying to think here. Okay, so the change in y is -2. I'm counting my slope here. Down 2 over +2 1/3. So if I want to figure out what my slope is, I really need to do -2 divided by +8/3. Now what you're going to get is the same thing that we had here, -3/4. You're going to get -6/8, and that's -3/4. There we go. Okay, now I got it right. Okay, so if I count this, you can kind of see right here that this point's on the line down 3/4, down 3/4. The lines are in fact parallel. They have the same exact slope, and so what that means is they're never ever going to intersect as long as they exist. And for our purposes, we're just going to write there's no solution to this system. There is not a single point that would satisfy both equations because the equations are parallel and they're never going to cross. Okay, so watch out for those. That does happen sometimes. Okay, finally, here's just a page of notes for you. Most of the time, you're going to find that the two lines intersect, like in this first case. That means that there's one solution, the point where the two lines cross. We call that consistent and independent. Consistent meaning there is a solution, and independent meaning there's only one. The second possibility is that when you simplify both equations, or when you go to graph them, they're actually overlapping lines. The first line and the second line are the same line, even though the equations might not always appear to be the same. We call this consistent and dependent. What happens is there's infinitely many solutions because every point on the line is also on the other line, and so every point is a point of intersection. Consistent meaning there's a solution, dependent meaning this time that there's infinitely many. And then the last possibility we just saw, if the two lines happen to be parallel, they're never going to crisscross, and that means there's no solution. We call this an inconsistent system. Okay, so I'm going to have you try one on your own now. I've got two equations here for you. You need to graph the system and then figure out if you have a consistent and independent, consistent and dependent, or an inconsistent system, looking back at that last page of notes.